All right, welcome back to another thrilling statistics warm-up. What do we have here? Well, suppose you want to know the average amount of money spent by fans attending opening day for the Indians baseball team. You get permission from the team's management to conduct a survey at the stadium, but they will not allow you to bother the fans in club seating or box seats, which is usually the most expensive seating. Using a computer, you randomly select 500 seats from the rest of the stadium. During the game, you ask the fans in those seats how much they spent that day. All right, provide a reason why this survey might not yield a biased result. All right, well, hopefully that piece should be pretty obvious. You're missing the fans that bought the most expensive tickets. Who were more likely to spend money. All right. And then if we want to comment on like the direction of the bias, we could say your results might be biased towards a lower amount. All right, now this one doesn't explicitly ask you to talk about the direction of the bias, but a lot of times it's good to think about that. Like if you think there's going to be bias, if you think there's going to be a problem here, what do you think the direction of that bias might be? So if you're leaving out the people buying the most expensive seats, those are presumably the people that have the most money to spend, and they might spend more on food, souvenirs, etc. You know, if you're spending $5 on your seat because you're in the top corner of the upper deck, you're probably not then going to go spend $500 on a bunch of other random garbage at the game. All right. So again, based on the way they set up their survey, they might get a result that's biased in a downward direction. All right, explain whether the reason you provided above is a sampling error or a non-sampling error. So again, sampling error is when you make a mistake designing your sample. Non-sampling means that you came up with a good sample, but something else went wrong. So this would be a sampling error. Because we made the mistake of excluding certain customers. All right, so this one's kind of on us because when we designed our sampling procedure, we excluded a certain group, and that exclusion is probably going to lead to bias in our results. All right, number 2, investigators chose a SRS of 880 drivers to answer questions about their driving habits. One question asked was, recalling the last 10 traffic lights you drove through, how many of them were red when you entered the intersections? Of the 880 respondents, 171 admitted that at least one light had been red. Do you think this result could be potentially biased? Why? What is the direction of the bias? All right, so this is something that shows up a lot in surveying, is that people tend not to admit when they're doing something wrong, especially if you're asking them face to face or over the phone. All right, when you want to get somebody to admit to doing something wrong, the survey has to be as anonymous as possible. All right, now if I were to suddenly ask everyone in this room right now, even though you're not in a room, you're watching a video, have you ever had an alcoholic drink before the age of 21? All right. Now, I'm sure some hands would go up, but some hands probably wouldn't go up because you'd feel awkward admitting that in front of a teacher. And then some hands would stay down because you, in fact, haven't had a drink. But the odds of me getting accurate results are pretty small, all right? Because people don't like admitting when they've done something they know is against the rules or wrong. So the result is probably biased because people don't like to admit breaking the rules. The true number is probably higher than 171. All right, so again, just another thing that you have to consider when designing a survey is depending on the types of questions you're asking, you have to think about the format in which you're asking them because that can affect the reliability of the responses you're going to get back. All right, comment on each of the following as a potential survey question. Is the question clear? Is it slanted towards a specific response? All right, some cell phone users have developed brain cancer. Should all cell phones come with a warning label explaining the danger of cell phone use? All right, so obviously here, this first sentence is putting this thought in your head of, oh, some cell phone users have developed brain cancer. That's scary. Should they come with a warning label? Of course, obviously, if people are developing brain cancer. So that first sentence biases people towards wanting a warning label. All right, and this is kind of what I'm talking about last class, is that there's all sorts of ways the surveyor can organize the questions or change the wording or to include, little descriptions that are going to subtly bias people in one direction or another. Now, is it going to bias somebody that has a really strong opinion about a topic? Probably not. But is it going to bias somebody that's kind of like not really thought about it and just kind of like, oh, all right, yeah. Those are the people that it's going to shift in one direction or another. All right. B, do you agree that a national system of health insurance should be favored because it would provide health insurance for everyone and reduce administrative costs? All right. Here's another perfect example. So if you're going to tell me that you can provide health insurance for everyone and reduce costs, why would I be opposed to that? All right. The way they've worded this question, it's going to bias people to say yes. All right. So here, the wording of the question biases people to be in favor of national health insurance. And again, it's not hard to imagine another way to word this question that could bias people to be against national health insurance. But then when you get the results, are you really getting people's true opinion about national health insurance? Or are you getting people's, influenced opinion by the wording of your question? So you've got to be careful how you word these, or if you're trying to get a certain result, then you've got to be careful how you word them to make sure that you're biasing people. A little less ethical there, but it happens all the same. C, in view of escalating environmental degradation and incipient resource depletion, would you favor economic incentives for recycling of resource-intensive consumer goods? All right. So, a couple of things going on here. One is just the wording is overly complex, and it is biased to encourage supportive recycling. All right, so first things first, there's going to be enough people that are just totally confused by that question and don't really understand what it's asking. And even then, those people that aren't confused by it, it's still being worded in such a way that giving escalating environmental degradation and incipient resource depletion, that sounds horrible. Of course, I'm in favor of economic incentives. So they're kind of, the double issue there. One, the wording is just overly complex. It's going to confuse people. And two, it's biased to encourage supportive recycling, which, again, may not be a bad thing. But if you're trying to get people's true opinions, it's hard to do that with questions like these. All right, and these are all examples of non-sampling errors, all right, because they have nothing to do with how we selected our sample, but once we had our sample, the way we collected our data had some issue with it, okay? All right, let's take a look at the back. A University of Helsinki study wanted to determine if chocolate consumption during pregnancy had an effect on infant temperament at age 6 months. So basically, if the mother ate chocolate during pregnancy, was the baby more likely to be happy or content or whatever? All right, so researchers began by asking 305 healthy pregnant women to report their chocolate consumption. 6 months after birth, the researchers asked mothers to rate their infant's temperament, including smiling, laughter, and fear. The babies born to women who had been eating chocolate daily during pregnancy were found to be more active and positively reactive, a measure that investigators said encompasses traits like smiling and laughter. All right. Was this an observational study or an experiment? Why? All right. So this would be an observational study. Because the researchers did not apply a treatment. They just observed the mother's behaviors. All right, so they didn't say, okay, this half gets chocolate and this half doesn't get chocolate. They just observed what these women naturally did and then tried to find associations between their behaviors and the temperament of their children. So what are the explanatory and the response variables in this situation? Well, we're looking at chocolate consumption. So they're trying to identify the explanatory variable as chocolate consumption. And then they're trying to explain infant temperament. So that's what they're measuring, how happy the child is. Does this study show that eating chocolate regularly during pregnancy helps produce infants with good temperaments? All right. So the answer would be no. It shows there is an association but correlation, here's our saying, does not equal causation. All right. Without a controlled experiment, we can't be sure one variable is causing the other variable to change. There could be lurking variables. All right, so it might not be that chocolate has any true effect on infant temperament. It could be that eating chocolate put the mother in a better mood, and when the baby saw the mother in a better mood, that caused the baby to be in a better mood. So it has nothing to do with the chocolate. Anything you could do to put the mother in a better mood might help the infant's temperament. Right? Chocolate might just be some mothers like chocolate, so it puts them in a better mood, and then that puts their baby in a better mood. All right. So the way this study was conducted, there's no way to say that one is causing the other. There's an association, but we don't know whether that association is really meaningful or there's something else, a lurking variable that's driving the actual connection between those things. All right, so again, we can only really ever say that one thing causes another thing if we're doing a controlled experiment. All right, observational studies are not enough to explain or to conclude causation. Finally, last question here. A student project measured the increase in heart rates of fellow students when they stepped up and down for 3 minutes to the beat of a metronome. The step was either 5.75 or 11.5 inches high, and the metronome was 14, 21, or 28 steps per minute. 5 students stepped at each combination of height and speed. Explain the experimental units, the explanatory variables, which are the factors, the treatments, and the response variables for the experiment above. All right, so this kind of goes into those vocab words that we did at the very end. So the experimental units, so let's just start here. Experimental units would be the 5 students that participated. All right, well, let's do response variable next because I think that one is probably pretty clear. So the response variable is what we're measuring. So that is their increase in heart rate. So it's probably just specifically the heart rate that we're measuring. Right? But we're trying to see if their heart rate increases. So the heart rate is our explanatory variable. Sorry, it's our response variable, not our explanatory variable. All right, response variable. All right, our explanatory variables are basically step height and metronome beat. All right, those are the two things we're altering to see how they affect the response variable. And then the treatments are the specific conditions applied. So the treatments would be all the different combinations. So what that means is it would be the 5.75 with 14, 5.75 with 21, 5.75 with 28, and then continuing on here, 11.5 with 14, 11.5 with 21, and 11.5 with 28. All right, it's the specific values or the specific conditions applied to our experimental units. So these were the 6 different treatments that were applied to our subjects. All right, so there were 6 different combinations based on our explanatory variables, and these were the exact treatments that were applied. All right, so by changing step height and metronome beat, We measured the change in heart rate on our 5 students that were our experimental units, and these were the various treatments that they received. All right, so I hope this was helpful. If you have any questions, obviously reach out. Otherwise, have a great day.